Okay, turns out that I really did just kind of pretend to make a mistake, and no, I just didn't follow the direction field very well, and there's a complication with this direction field, okay? It's not graphed very accurately. And I was going to mention this before, and I think that inaccuracy is the reason I got at least, misled about the shape of these curves, okay? So let me explain that. A slope of 1 means we go 1 unit in this direction and 1 unit in this direction, right? But this one is bigger than this one, right? So when I have a slope of 1, it should be steeper than the way I've got it, but I did draw it that way. Okay? So actually I don't see, but it just comes down to, I didn't draw this direction field very accurately. Okay? Okay. You can see the direction field this way or the other way. You come through here, you're never going to get over here to decrease the slope. You're going to come up here where the slope begins increasing. And of course then the slope approaches 0. So you're getting these curves. Does that make sense? Okay, what I was going to say about this, it doesn't look like that's necessarily the source of my misinterpretation. I was just careless in following the direction field. It really should be this way. Okay, and from here we really go up like this, but since we're going higher we do get steeper. It doesn't look right with this direction field, which means you got to be kind of careful how you draw it. Now, when I draw the direction field for 1, 1, that doesn't look like a slope of 1, does it? That's too steep. Slope of 1 would be there, except that we have different scales. So the scale here is, you know, our unit up here is bigger than our unit down here. Okay? Lane?
The farther out along you go along the t-axis, the slope is barely changing at all. Like for t of 3, it goes from 2/9 to 1/3 to 2/3.
Yeah, it gets pretty flat out here. But you see, your solution curves also get flatter and flatter. Vertical stretch of your y equals x squared graph for smaller and smaller values of a look like this, right? And what does that do to your direction field as you go horizontally? Along this horizontal line, it's like this, then it's like this, and they get a lot flatter as a approaches 0, right? Okay, and of course then they get steeper here and here, and of course then as you go up, they get steeper, right? Okay? So again, we appear to have a contradiction, but we really don't. Okay? I was just overestimating the influence of the flattening as you go this way relative to the steepening as you go this way.